Hello, welcome to the Deep Learning Podcast. I'm Kylie Whitehead, and I'm joined today by Dr. Ivan Vulić, a senior scientist at PolyAI and principal research associate and Royal Society University Research Fellow at the University of Cambridge. Ivan's published over 150 research papers on NLP, machine learning, and applied linguistics. And Ivan's here today to talk a little bit about his latest paper, which introduces Pheme, a new speech generation model from PolyAI. So hi, Ivan.
Hello, hi, Kylie.
So before we get into Pheme, what it is and how we built it, I'd love to understand why you'd even consider building a speech generation model at this point. I feel like there are loads of really good TTS systems out there already. So why did you feel the need to work on something different?
Yeah, because we are primarily like a voice-based company in the first place, and then we wanted to build something with our own hands and something that actually uh, is really good for our own needs. And then we tried all these different systems out there. Some of them are really, really great, and the quality was amazing, but it didn't really fit the bill. It didn't really fit our need completely because often it was like, I don't know, it was too slow. So we couldn't really run it in real time with like real systems, etc. And then we could only work with what was given to us. So we didn't have the full control over the system. And we just wanted to build something that is sort of enterprise ready for ourselves in the first place. And then maybe this will also spark more interest in building something on top of just, I don't know, sheer performance quality, something that we could really use in real systems and is fully controllable. And this is why we actually started that journey. I mean, another reason is also like, call it academic research curiosity. And we just wanted to build something with our own hands and really understand every little detail of those systems in order to kind of make them fully controllable in design and use later on.
Yeah, that makes a lot of sense. And I think one of the things that you discuss in the paper is the way that the research tends to ignore like real life applications. Like the research
Yeah.
is all about making things that sound good. And maybe they perform well for you to show at conferences, right? But actually when it comes to deploying them, they're a little bit more tricky.
Yeah, so there is this like dichotomy between academia and research. Like academia often likes to just, I don't know, create models to put some numbers in boldface, and then you have your paper publication, and then you really don't care if anybody was going to use that. Uh, Although, like more and more industry sponsored, industry oriented research is out there, but some of the industry research still competes with like academic goals and leaderboard, and we just wanted to do something that's like really practically useful, useful in practice, useful for us in the first place, and then we're happy to share it with the rest of the world. And yeah, that was one of the reasons. It's slightly different. So one of the things that we like to do in PolyAI's applied machine learning team in the first place is really to come up with new research ideas, but having the final application in mind, not just like the art for the art's sake type of thing, for example. Yeah. So
Yeah, I remember when I first joined PolyAI and having this discussion, I think with you, maybe with Pavel as well, about the data sets that this stuff gets trained on. I think we were talking
yeah,
about the like NLU models at that point. Um, and it being because of the sort of benchmarking in academia, everything gets trained on these same set of data, but it's not actually relevant to the real life application that you use this technology
yeah.
in.
So this Themes, like maybe if it will be like a model series, it actually follows the long journey, the long uh like uh, long term goals of PolyAI to really build like efficient and performance systems. So maybe uh like people know about the convert model, which was sort of like a revolution in like mini modeling, like efficient modeling, where everybody was talking about like a billion parameter models back in the day, and large models. We were trying to create something that fits like the mobile device memory and things like that. And then there is like there are people who actually appreciate that type of work. And like the bottom line is if you create like these smaller models, efficient models, you basically save money because they're like cheaper to run and cheaper to serve, all of these things that people in academia or people who have multi-million dollars to just burn on GPUs don't really care about. But yeah, I know
Yeah.
consumers do care about that.
Yeah, especially with the organizations that we're working with. I think this kind of technology has been available to like the Bank of Americas of the world because they have almost infinite money to spend on this, right? But when you start working with a lot more organizations, especially where we're facing budget cuts and everything in the last couple of years, it's been quite strenuous. In order to actually put this technology in front of people, it needs to be efficient, right? It needs to be accessible in that way.
I mean, yeah, a cool thing about this technology is really that, I don't know, maybe not my grandpa, but because he doesn't use a computer, but I know everybody, even like without any technical knowledge, can just try out the demo or just like type something and it will actually run and they might not be able to train the model, but they can use the model. They can take it as a black box and just plug it in with something else. It's something like that. And if you have like a gigantic model, which is completely obscure, nobody even knows what the model has been trained on, how it works, you can't store it anywhere, you can't load it into your memory, then yeah, you can't really do anything creative with it.
Yeah.
And yeah, this story of efficiency is related to product itself, but it's also related to more, I don't know, you can like democratization is maybe like an obsolete term now in AI, but it's still kind of bringing goods to people if you want to have this like more socialist, I don't know.
Yeah.
Yeah.
So tell me a little bit more about Pheme and why it's different to anything else that's out there and the purpose that it serves.
Yeah, so that's a good question because there's like a wealth of TTS models out there, and I mean, it basically, as we wrote in the blog post, it does stand on the shoulders of not giant, maybe like gigantic models, but so the main thing that we wanted to change was really, yeah, uh, efficiency of the models. And I can talk, efficiency has multiple layers. I'm going to talk more about that later on. And also, we wanted to make the model more conversational because what previous TTS models basically did, they were just training, for example, on audio samples from audiobooks and like acted speech, which all sounded very artificial. And when you're building conversational assistants, like what PolyAI does, we need this like lifelike, natural conversational experience. And this is like a very important aspect. And the second aspect was this efficiency thing. And I already touched upon that. So efficiency can mean like smaller models, which kind of it's sort of like parameter efficiency, so that you can easily store and load and quickly access all these models. You can talk about data efficiency because you can't really assume that you have like enormous data sets of audio for every single voice in the world. And if you want to quickly adapt the model, you need to do it quickly. So this is sort of this data, or we call it sample efficiency in machine learning. And the third aspect, which is also very important, is this inference efficiency. So we mentioned it paper and in the blog post also that you can't really talk to a system if the system takes 1 minute to respond to each of your questions. And then like going back to the conversational nature of it, if it sounds like it's just reading parliamentary proceedings, like to, I don't know, get babies to sleep, things like that. So yeah, that's
Yeah.
that's the reason.
Yeah, you covered a lot there. So going back to the experience, to how conversational it feels, right? I always think of this example with um, one of the Poly AI voice assistants. It's for a restaurant and it answers the phone like, "Hello, how can I help?" And it sounds like a person working in a busy restaurant. And I also like I listen to a lot of audiobooks, and I can understand how if you took that, how can I help from a different setting or a different, perhaps had different utterances before, after it would sound very, very different. So how can you, with a model like Theme, how do you sort of ensure that it has that right tone?
Yeah, I mean, a good thing is that because of the what I just mentioned, data efficiency, it's easily customizable. So we do uh, provide like these release checkpoints of the model, and that model has seen some conversational speech. So we actually took some publicly available data that comes from like YouTube and podcasts and this is conversational by nature, but it doesn't cover all the possible prosodies and how people talk, but it covers a lot. And and so if you really want to elicit a certain conversational behavior for your own brand, you can just maybe provide like minutes or like several hours of samples of how the bot should sound like. And then we can start from this like general conversational model and then customize it to your own brand needs. And this also comes with like different voices. So the model is a multi-speaker model, so it has seen a bunch of voices from all these like YouTube podcasts, etc., etc. But if you want your own brand voice, it's just easy to continue fine tuning. It's sort of this transfer learning paradigm again, which is still very prominent in machine learning. And then we can customize that. So we have this use case in the paper as well, where we actually took a brand voice and synthesized synthetic data, like 5, 7, 10 hours of data. And then we basically showed, okay, now like Pheme can speak in that voice very accurately with very high fidelity. So this, I mean, we had so many requirements that we wanted to really satisfy with Pheme. This was actually pretty tricky, and we always missed one point, and then the final architecture really like reflects all these requirements that we wanted to satisfy as part of the work.
When you say trained it on that brand voice, like could you take your voice, for example, and make it speak in your voice?
Oh yeah, yeah. So we can do all sorts of things. Some of them like could have potential problems, but yeah, that's another story on like. But
Yeah.
basically, we can take like hours of YouTube audio or video of a particular person. We can like sample it to 16 kilohertz as we do in the paper, and then fine tune the model, the current checkpoint on that voice, and the model will start speaking with that voice. I mean, a good thing is like when I mentioned the ethical problems, etc. There are like guardrailing tools that actually can tell you, okay, this is synthetic voice, so no worries that this is not real human speaking. So there's always like the uh, detection slash mitigation strategy. And yeah, the primary purpose is really to use it for our conversational assistants. But yeah, so
Yeah,
yeah,
okay.
no, I would just wanted to say that Femi can speak like you or me or like anybody who gives us enough voice material to fine tune the model on.
That's so when I was speaking to Pavel about speech generation a few episodes ago in this podcast.
Yeah.
And the first thing that came to my mind when he was talking about this concept um was around voice biometrics and the implication that this kind of technology has for voice biometrics. But you're saying that their sort of voice biometric systems will have that safeguarding in place where even if you create a copy of my voice, it will be able to say, no, this is a synthesized voice. This isn't a real
Yeah,
human.
yeah. So there are like dedicated classifiers which can capture these like subtle nuances. So they might not be fully audible to humans who are not trained, and maybe they capture some really like like latent part of the whole signal, but those classifiers work with like 9 point something precision. So I shouldn't be too worried. So yeah,
Yeah, I think that's the scary side. But on the more exciting side, I guess you have a real opportunity to create a brand voice, a brand character. And you can think of
yeah,
applications for that. Like an obvious application would be like Disney, right? Could launch a voice assistant in Mickey Mouse's voice or, and have it say whatever without having to have voice actors or whoever recording that beforehand.
yeah. So I think there are more applications that we even like anticipate right now. And yeah, I didn't really think about Mickey Mouse voices, but maybe some brands would actually like that. So this is something again going all the way to the beginning of our chats when we discussed why building this in house. It's also because without third party providers, or if we actually do it ourselves, then we can actually choose which type of voice we want, and we can build stuff for virtually any voice we want. And with third-party providers, we're just limited to the voices they provide. So, I mean, we can ask, if we have N voices, give us N plus first voice, but then it takes time to build, et cetera, et cetera. And this way we just say, yeah, okay, we want Pheme to speak like Donald the Duck. No problem. We're going to just get some samples of Donald the Duck and we're done. Yeah.
Yeah, I think, when you call up, we speak to a lot of IVRs now. It's quite a generic, often robotic voice. And I think that the thought given to brand often happens at the side where you're selling the customer something. But when it comes to sort of customer service after the fact, it's a very different brand experience. And I think this sort of technology enables brands to create like a really consistent voice and feel across all of their customer touch points, which is really exciting.
Yeah. So, I mean, this is not touching on the conversational nature of TTS that we wanted to really instill into the Pheme model, because we felt like trying out many different TTS systems before that, a lot of them like sound like Terminator voices, basically. And I mean, I was scared of some of the voices. Um, but like, to be honest, in the last year or so, like the whole text to speech research field has seen some tremendous improvements. So this also inspired us. Okay, now might be the right time for us to step in and do something ourselves, because we collected now a lot of experience trying out different things. We read so many papers about the subject, and then we felt comfortable enough to dig deeper into the whole construction process.
Yeah. Okay, cool. Well, Ivan, maybe you could show us some examples of what you've been able to do with this model.
Yeah, so I'm happy to do that. So yeah, we have a page with some demo samples. Um, I'll need to slightly explain what actually we have out here. So yeah, the details are in the paper, but one really, I would even I'd say, cute feature of this model is basically you can prompt it. So we've heard about prompts in the context of large language models, and here we can actually do generation of speech in a voice that has been previously unseen by the model. If we just provide like a very short prompt of like a couple of seconds, and then the model will actually generate speech from text in that same voice. And how that works, you can find it out in the paper. But here is just like a short demo. So first, this is the prompt that we give to the model.
Let's just say, in her own word, once I sat down and watched it, I never moved. I was enthralled by it.
So this is the only audio sample that we have from this particular speaker and this particular voice. And then what we want to say is the reference text here. And she told me the next time she went back, she would take me blah, blah, blah. And so we are generating that part, just conditioned on the prompt audio. And then we provide like three different variants of the model. So the number in the parentheses means that this is the number of parameters. So the larger model is slightly better as expected. So like you always trade off performance and quality, but this is like a very small model in terms of standard neural architecture. So I'm just going to play this variant here, which is I think, the best performing model out there. And yeah, this is.
And she told me the next time she went back, she'd take me with her. And I waited, of course, like I said, 13 years.
Yeah. So again, to just repeat, so it was like a one-shot generation. So we just heard the model just heard only a couple of seconds of audio of that speaker. It has never seen that speaker at training, etc., and it managed to generate speech from given text with very high fidelity. And then we have a bunch of similar examples here. So I'm just going to play another one. Okay, just one.
So I think there's a range of risks, but generally speaking, there's going to be a steady increase in the floor of the skill level as these AI technologies diffuse.
Okay, so that's the prompt. Yeah, sorry.
So that's a real person talking, a bit of audio recording, and that's what you're using then to have Pheme copy.
Yeah, that's a real person extracted from either YouTube or some podcasts.
Yeah.
And this is the prompt. And now we're going to generate a sentence, which is in the reference text. This is going to sound like this.
That is, there will be more and more capabilities available to people at the bottom of the scale. That is, individuals as well as people with more access to computing power, money, and data at the higher end.
Yeah.
So a well-trained ear might actually hear some differences between the two voices, but then again, like measures of speaker similarity, and one of our goals was really like to increase the score on speaker similarity. And I think like average or not so well-trained ears might not even spot the difference. And yeah.
Yeah, I think this is fascinating, and this means that yeah, you can generate these prompts from scratch very quickly, I'm assuming.
Oh yeah, so that's the efficiency aspect also. So
Yeah.
yeah, it just takes, I don't know, less than a second for short audios. So, this is one of the things that we also discuss in the work. So one of the primary driving forces of our work was really like to reduce what we call real-time factors. So that means that we can process longer text in as little time as possible, because this is one of the key or like killer things for the final application. So we again go back to the whole design of conversational assistants and all those systems. You might actually get latency from automatic speech recognition. And if you have a large language model, so if you play with GPT-4, it takes some seconds to actually get your text out. So if your TTS is very slow, you will never end in your processing thing. And we wanted to really cut down the time needed for processing for text to speech down as much as possible, so that we can actually save some time for large language models to generate things.
Yeah.
And yeah, so we achieved like a pretty decent speed up. I would say, how much was it? Like 15 times quicker than some like other autoregressive models, which really gets speed from, I don't know, having to wait for 30 seconds for like a 5 to 6 second sample to just doing it in half a second or something like that. So
Yeah. Wow. That's one of the most frustrating things when you speak to an automated system as well as a consumer, is when there's that, there is that latency. You really don't know if it's still listening out for something, if you're like expected to add more. It makes
yeah.
it very strange as a user to know what's expected of you. So, Ivan, I feel like I've heard some examples of versions of this around the office with various co-workers like this. It seems like you guys might have had some fun testing this out and trying variations of it over the past month.
Yeah, I mean, we can train like brand voices with people from the company, which
Yeah.
might be quite fun. And then I know we could. This is something that actually happened to me a long time ago when I was playing with those TTS systems, and it sounds really weird when you talk to yourself. So you're both the agent and the system at the same time. So this is possible with this technology, more or less.
Yes. Well,
Yeah.
maybe we'll have to see about doing some kind of variation on this podcast using this technology. I think there could be
Yeah.
some really good fun that we could have here. So this has been great, Ivan. Thank you so much for taking the time to explain this to us a little bit. As Ivan mentioned, you can find out more about Pheme on our website. If you navigate to our blog and go to our latest blog post, you'll find it there. And from there, you can go in to read the full paper and visit the samples that Ivan just shared. And if you like this episode, you can go back to episode 13, where I spoke to PolyAI's head of machine learning, Pavel Budzianowski, who co-authored this paper with Ivan, where we speak a bit more generally about speech generation. But until next time, thanks for joining us. Take care. Bye.
Bye bye.